Hi, this is Jason Jacobs with TechwareLabs.com. We are here in sunny San Jose at Western Digital's campus to bring you some latest development and innovations in the realm of big data. I have with me Dave Tang, who is the Senior Vice President of Corporate Marketing and Communications for Western Digital. Dave, thanks for being here. Tell me a little bit about your role here at Western Digital.
So as the Senior Vice President of Corporate Communications and Marketing, the role is to position the company as well as our entire portfolio from consumer and commercial and enterprise products to the marketplace.
Very cool, very cool. Just so my readers are familiar with what's going on, can you tell us a little bit about why we are here today?
Yeah, so this event today is about some breakthrough technology that will help to drive the density of hard drive capacity up for a decade and more to come. So one of the challenges that we've had with any technology is that as we get towards the end of a technology cycle, the gains that we get back from ongoing development of that technology start to taper off. So this is really the announcement of the next wave of technology that's going to take us
This is really awesome. We saw a lot of really cool late-breaking innovations in big data and hard drive development and storage development and technologies associated with how we store and write that data. And you can see more of this on our website and our social media channels, obviously TechwareLabs.com and Facebook/TechwareLabs. But what we're talking about here today really revolves around two main things. There's some storage developments in terms of actual physical hardware, and then we are here mainly to discuss big data. And what is big data?
Okay, so big data, I think the term has become popularized, but it's really about amassing large amounts of data, generally unstructured data from a variety of sources, and then that data is used for a variety of purposes, but one main purpose is to gain insights and connections between different types of data so that you can make predictions. You can predict perhaps where the stock market is going based on data, or you can use it to develop algorithms to control real-time systems. A good example of that would be for autonomous vehicles. You know, that those algorithms are built on big data, even though they run real-time in smaller real-time data sets.
So for you guys out there who are consumers, big data is more like huge sets of real-time infographics and that kind of thing coming in. If you could put it on a smaller scale, what you're talking about is basically an Excel sheet with not thousands of lines of data. We're talking millions or billions of lines of data, and how to analyze that data and interpret that data in a real-time, fast-paced environment. Who is this applicable to? Obviously, your at-home standard user with a laptop really isn't concerned about big data, or should they be?
Well, they certainly can be. I think the applications for big data span a lot of different environments and applications and users. So anywhere from consumers, where perhaps facial recognition, you go to a social media site, you upload a photo, magically they identify who's in the photo. Well, they do that based on big data because they're able to analyze a large number of photos and look at that biometric data and with a high level of accuracy. And then it also spans into businesses. So, for example, a bank that wants to detect fraud with credit cards will look at billions of transactions, knowing which ones were fraudulent, which ones weren't, and using that data as well as location data, time of day data, they'll be able to derive out algorithms that are used in real time to alert you, maybe send you a text message if they feel like a
So what we're really talking about here is analysis on a very grand scale of huge sets and amounts of data to form patterns and analysis to predict what things are occurring either now or in the future.
That's right. Yeah, the idea is to get more precise predictions and more prescriptive directions or recommendations for things as opposed to a simple average.
Right. And so the reason that this is coming about and why we're here today with Western Digital is obviously if we're talking about large sets of data, this stuff needs to be stored somewhere. We are talking about information warehouses, NAS drives, cumulative cloud data, and of course Western Digital being one of the premier offerings in storage, they're offering the ability to increase capacity and technologies that drive where this data is stored, how it's being looked at. Tell us a little bit more about your role in big data.
So Western Digital has a view of the market and the uses of data that simplifies into two types of data, big data and fast data. Fast data is, as we talked about, a lot of real-time applications. That's generally supported by solid-state storage devices like flash or in-memory applications. For big data, the whole idea is to be able to store larger and larger amounts of data and keep it for longer and longer periods of time. And what's really important from an infrastructure standpoint is that that capacity be provided in a very cost-effective manner on a TCO, total cost of ownership basis. So the density of the systems is important, the amount of power that's consumed for those systems is important, in addition to just the bare capacity of a device. So our role is to help drive the densities and reductions in cost per terabyte down to make it more affordable for organizations to store more and more data so that they can make better decisions.
You gave a presentation earlier, and one of the things I found interesting is that you're looking at not a 3-year or even a 5-year timeline of storage. You guys are projecting as far out as 10 plus years, and you're looking at development of technologies for the next decade, for consumers, for businesses, for enterprises, and we're talking about large storage arrays, diverse storage arrays across basically the globe. And so Western Digital came up with a technology. As a matter of fact, they invested into 2 different technologies to determine which one met consumers' needs, enterprises' needs, storage needs over the next decade. And they came up with something called MAMR, which stands for
Microwave Assisted Magnetic Recording, or MAMR for short.
Which is interesting, and basically what we're talking about is the ability of a hard drive to record data on a really small scale becomes more difficult the larger you scale the storage. So Western Digital developed a technology to embed. Tell us a bit more about it.
Right. So the idea is, in order to store more bits in the same container, a disk drive size container, the magnetized areas need to get smaller and smaller. It just makes sense, right? Higher density means each element needs to be smaller and smaller. And the challenge is as those elements get smaller and smaller, it's harder for them to retain their charge because they're packed together and the magnetization that's pulling from adjacent bits starts to affect it. So what we've done is we've developed a technology that adds energy to the recording media, the thin layer of magnetic recording substance, that allows it to be magnetized at a much lower magnetic field while we're writing data to it. But then once we remove that field, it's able to retain that data without inadvertent erasure or loss of charge. So this is, generally speaking, it's called energy-assisted magnetic recording, where we're injecting energy. So our big breakthrough was that we have been able to take a spin torque oscillator, which is a mechanism, electronic mechanism, which emits a microwave field, and actually embed that into a recording head so that we can emit this microwave field while we're writing data to the disk.
To add energy so you can
so that we can record at higher densities without risking that information.
And this is Western Digital patented technology.
Yeah, so the general concept of microwave-assisted magnetic recording and even spin torque oscillators are not necessarily proprietary to Western Digital. What is our own innovation and development is the ability to develop this spin torque oscillator, embed it into a recording head, and be able to focus the beam in such a precise way that it can increase the density that we're recording. Because if you can imagine, if we were not able to contain the beam in a sufficient way, it would spray,
right,
kind of like overspray and with spray paint, and you wouldn't be able to take advantage of that field.
And this is exciting for 2 main reasons, especially in the enterprise and business environments. Number one, the cost of development and deployment of these drives is not going to be significantly higher than your drives that you're buying now. So you can rest assured, and 2019 is your expected release date for MAMR drives?
Yeah, so we'll start sampling the drives in 2018 and begin shipping in production in 2019.
And you're expecting capacities upwards of 40 terabytes, if I'm not mistaken.
Yeah, in the 20-25 type of range, we feel that those capacities are achievable. Sure.
Okay. And MAMR technology, can we expect to see this implemented, or even is it feasible to implement this on consumer drives?
Of course, it's feasible. Once we have the ability to embed the technology, the spin torque oscillator technology in the recording head, we could use those recording heads in a variety of different environments and products. I think in terms of consumer devices, the question really is whether consumers will need those increased densities, because certainly the cost per terabyte will go down, so that makes it attractive for everyone. But then the question is, will consumers need those capacities in their devices, in their notebook computer, or will they opt more for, say, an SSD product?
And I was just going to say, I can hear my readers screaming right now, guys. Why are we not investing more into flash storage versus traditional spindle drives? And again, this comes down to a cost ratio. Flash drives are still much more expensive than your spindle drives, but in the future that cost will drop. Do you expect at some point for the two to cross, where we're talking about spindle drives going away and flash storage eventually becomes as scalable in capacity to the spindle equivalents?
Yeah, that's a great question, and it's always key when you have complementary technologies in the marketplace that sort of track one another. If there is a crossover point, then you're going to want to know that, and that in part is why we planned and do research so far in advance, to your earlier point. So I think that the beauty of this technology is that it helps to track the gains in cost per terabyte with SSD, so that the two track together out in the future, and they'll keep a separation of about 10x or greater in terms of cost per terabyte. And with that kind of separation, you don't really have the effect of one market flipping over to the other. So it will remain complementary as far as we can see for the foreseeable future.
And MAMR struck me as a transitory technology. You guys are still investigating, or I would expect you're still investigating, technologies beyond spindle hard drives, beyond traditional storage, even SSDs. I expect that's, of course, occurring in some back lab with shielding on the walls and people wearing tin hats.
Sure. Well, there's still a few tricks up our sleeve when it comes to magnetic recording, so there's still ways for us to enhance and drive those densities higher, even beyond what we're doing with MAMR. And with solid-state technologies, of course, we're doing a lot of research into next-generation non-volatile memory. So beyond the NAND technology that's used for flash, we're looking at MRAM and ReRAM technologies that will provide a next generation of performance that sits somewhere between DRAM and flash at a cost point that's also below DRAM and closer to flash. So advancements on both fronts.
As I said, it looks like Western Digital is making progress on multiple fronts. They're not one to put all their eggs in one basket. And what we have, back to big data again, I had a question from our readers about when consumers will see big data benefits to them on a personal level. When do you expect the big data to make a transition from something that primarily organizations and businesses are interested in to something that actually benefits consumers in their daily lives?
Right. Well, I think consumers are seeing that now. I think that they may not necessarily attach the benefits to big data, but I mentioned before, credit card fraud protection. That certainly helps the consumer. Yes, it helps the bank, but it also, if you've ever had a fraudulent charge on your credit account, it's a hassle, right? So to save that, and I think also what you see in recommendation engines as
exactly.
You might shop,
so what you guys may see right now is benefits that you're not tying to big data, but obviously these search analytics and benefits to things like your checking account, your credit card, and that kind of things are coming from analytics of large sets of data that globally come in every day. And of course, some of them are based on your personal habits. Another question from my readers was, do you think that home users will have a secure way of storing data for long periods of time in the near future?
By secure, are you referring to the preservation of that data and the ability
I would
to
expect
read
that
it, or
they're
secure?
really thinking about it from two standpoints. Not only access to it so that data is not lost, but also the security of that data so that the wrong people don't get access to that data.
Right. Yeah, so many of the technologies used at the system level for storage are doing background scrubbing and verifying that the data it currently exists in the way that it was written, and if not, it will apply correction algorithms to restore it. So there are technologies that help to ensure that data is durable and it's not lost over time. From the standpoint of security and authentication and access control, that's a little bit of a different story, because generally speaking, what controls access to the data lives far above the storage layer itself, right? It's your passcode or your fingerprint that gets you access to your phone, and once you get access to your phone, then it gives you access to what's being stored on that phone. Similar to enterprise IT systems, you have to be authenticated to gain access. So that layer generally sits above the devices. We do have devices that do encrypt themselves and have an instant erase feature, which means you just pull the encryption keys in case it's lost. But in terms of the basic drive level, it would be redundant to apply some sort of password authentication at the drive level on top of what's already being done at the operating system or system security level. So we want to make sure that we're not bumping into other measures that are already in place.
It's an interesting segue to the next question that one of our readers has is, will WD ever offer a storage device with integrated encryption and a specific system to manage that data?
Yeah, so as I mentioned, we do have products, and our enterprise drives in general have onboard encryption capabilities in them. So they need to be used with systems that take advantage of that feature.
I think that the reader was more focusing that on big data sets, for example, things like Hadoop and that kind of thing. They were thinking more along the lines that you partnered with that company, and that's great. It may be a bit more technical than most of my readers are capable of understanding, but you partnered with that company. Why not invest into your own solution?
Generally speaking, for when we're selling products that go into building up infrastructure for, let's say Hadoop, that infrastructure is not necessarily directly interfaced by the users. There's usually a layer that sits above that. In this case, a Hadoop layer, where the interface to the user is that application. And by providing a single point of interface to provide not only the function of Hadoop for analytics, it also provides the security layer. If we provided a layer on our own, then we would have to wait for all the application providers to then adopt and utilize that interface, and then as we changed and improved the interface and they improved, we have potential issues of
and one of the things that I identified as a response to this myself was obviously Hadoop is a open source, so it's open to the community, and development options are much greater along those lines. Dave, I really appreciate your time. Thank you for joining me, and thank you for your time for my readers. Look forward to great developments from Western Digital. As always, stay tuned to TechwareLabs.com for more developments. We'll have all the presentation slides and media from today, as well as a lot more information on our website and all social media. Thank you for tuning in. And as always, if you liked what we had to see, send us questions. We're sure to answer them. Thank you for tuning in.